Hello everyone, I am Ashile, currently pursuing my bachelor's in chemical engineering from Vellore Institute of Technology, and I will be explaining about the paper Predictive Big Data Analytics for Drilling Downhole Problems. So within the recent introduction of data recording using sensors in exploration and drilling and production process in oil and gas industries, the industry has turned into a massively data intensive sector which collect large amount of data which is harder to handle, and most of the data are unused. Big data analytics has acquired a great deal of interest from researchers to extract and use these various information. So in this regard, we have taken drilling downhole problem analysis using different optimization algorithms from the data which are collected through sensors. So this is the basic chart which explains the procedures that is taking place. So from the oil and gas industries, during the drilling process, different downhole problems may occur, such as dogleg, pipe failure, pipe sticking, etc. So with the sensors which are already presented, which collects a large number of data, and these data will be stored accordingly, and using different algorithms these data will be analyzed, and predictive algorithm will help us in identifying if there is a possibility for downhole problems, which will be displayed using predictive windows, and adequate alarms or warnings will be given for the engineers who are working in the premises. So using these warnings, the person in charge can easily deflect or create different scenarios which will not cause these downhole problems. So I'll be explaining the methodology now. So the methodology part has been separated in 3 phases. In the methodology, we'll be explaining it in 3 phases: phase 1, phase 2 and phase 3. In phase 1, the identification and collection of data for various different pipe sticking problems will be identified. In the second phase, the storage, management and using of effective algorithms will be studied. And the third phase, the usage of risk predictive windows and usage of game theory for selection of the best algorithms, and the display of solutions or alarms will be also explained. So the first phase, as we have different downhole problems and various factors may cause them, pipe sticking, dog legs or pipe failure, different parameters will have to be assessed, and inspection of all the data during the drilling has to be accounted. So usage of these data will be taken into phase 2. The collected data will be analyzed through different technologies and stored and managed, and various softwares or programs will be used for this, such as Cassandra, Apache Hadoop, MongoDB and MapReduce. From these, patterns will be created to be fed into predictive model, and the predictive model setup is created in which different algorithms will be checked. So we have given 3 examples here: ANN algorithm, support vector algorithm and decision tree algorithms. So using these different optimization algorithms, These will be displayed in a risk predictive window which is given in phase 3. This risk predictive window will showcase the possible failures in the drilling, and the pipe failure, pipe sticking and dog legs will be revealed, which will continue through alarms and solution, which will alert the engineers who are working in the plant or the drilling rig. And finally, the game theory will be used for identifying the best predictive algorithms from the given ANN, support vector, decision tree algorithms, etc. So it may be economically more viable. The next will be explaining about the algorithm. So from the start, the predictive model has to be defined on the downhole drilling problems, in which the feeding of the parameter patterns analyzed using different big data technologies, as explained earlier, will have to be given. And then condition prediction using different models, in which ANN algorithm, decision tree algorithm, support vector will be used. And using these, definition of training, testing and validation of sets will be done. So in this, define training criteria and define design parameters, which will lead to model training, and upon successful model training, it will lead to model validation, and in unsuccessful case, it will return to the condition prediction using different models, in which different other algorithms will be checked and used. And the model validation, the actual versus predicted outcome will be checked, and the suitable model will be used. In case of criteria, the training, testing and validation sets will be redone or modified accordingly. This is the flowchart for the selection of the best algorithm using game theory. So first, the data, which are field data, real-time data and test data, are collected, in which downhole algorithm prediction model with variables such as cumulative drilling hours, temperature, drilling data, training and model parameters fitting validation of models, and using this predict the probability of finding the best model. And finally, the efficient model will be dictated using game theory for the usage of downhole problems, which is very beneficial in an economical aspect. So for the conclusion, in the paper we have extensively discussed about the framework for the predictive big data analytics, which we will be using in oil and gas industries, and we have explained about the utilization of data recordings, sensors for exploration, drilling and the production processes, the identification of downhole challenges using various big data methodologies, the evaluation of predictive models using risk prediction windows, and game theory is also explained in the paper. So I thank you everyone.